Today I'm going to be talking about solving quadratic equations, and this is the first day of Chapter 4, Section 1. So there's a few reminders, okay, or a few questions to answer. It says, how many solutions, zeros or roots, we can call them any of those, can a quadratic function have? Well, it can have 2 solutions, 1 solution, or no real solutions. And right now we're going to say no real solutions because later in this chapter we are going to be talking about imaginary numbers, and that no real solutions will change. So what does this look like on a graph? Well, if we were to graph a parabola, we're going to have 3 different ones here. If we were to graph a parabola, it would look something like this. And the solutions would be the intercepts on the x-axis. So that would be 2 solutions. 1 solution is where the vertex just hits once. So that's 1 solution. And what you call, floating, if it's floating, if it doesn't actually hit the x-axis, this is a no real solution. And I'm going to show you what that looks like algebraically with square roots. Okay, so if we have something like x squared equals 4, if we square root both sides, don't forget to do plus or minus, it would be x equals plus or minus 2. So that would be 2 solutions. If we have something like x squared equals 0, and we square root, 0 is not positive or negative, so that's 1 solution. And if I have something like x squared equals a negative 4, and we square root it, that would be no real solution, because for right now we can't have a negative in that radical. So that's no real solution. Okay, so we have to keep that in mind. We can have 1, 2, or no real solutions for right now. And I'm going to show you several different ways how to get these solutions. The first one is by graphing. So we have to remember how to graph a quadratic equation. So we can do our x equals negative b over 2a to find our vertex. And we have to have our axis of symmetry as well. So this is going to be a negative 2 over 2 minus 1. So that's going to be a 1 for us. And the axis of symmetry is x equal to 1. And then remember, we have to plug it back into the original function to get our y value. So if we have a negative 1 plus 2 plus 3, negative 1 plus 5, that would be a 4. So our vertex is at a 1, 4. So we're going to graph our axis of symmetry at 1. And our vertex is at 1, 4. And then we pick 2 points to plug into a table of values. I'm going to pick 0 because that's easy. So 0, 3. And let's try negative 1. So we have a negative 1. It's going to be a negative 1 minus 2 plus 3. So that's going to be 0. So let's graph 0, 3 and reflect it. And then negative 1, 0, and then reflect that. And now we can see where the x-intercepts are, and they are at negative 1 and 3. And those are our answers, and that graph has 2 solutions. Let's do another example with graphing. Okay, so this one we have to get into standard form. So we have x squared minus 2x plus 2. And now we can do our x equals negative b over 2a. So that'd be 2 over 2 again, and we get 1. So our vertex, our x value is 1. And if we plug that back in, we do 1 minus 2 plus 2. And that would give us a 1. So our axis of symmetry, once again, is x equals 1. So let's graph that. And our vertex is at 1, 1. And then let's do a table of values real quick. Let's try 0. If we try 0, that'd be 2. And let's try a negative 1. Let's try negative 1. So we do 1 plus 2, which would be 5. So 0, 2, reflect it, and then negative 1, 5. 1, 2, 3, 4, 5, and reflect that. Well, when we graph this, there are no x-intercepts, so this is no real solutions. All right? Now let's talk about using square roots. This is another method that we can use, is square rooting. So what we're going to do first is square root both sides. Don't forget your plus minus. So we have p minus 4 equals plus or minus 7. Move the 4 over, and we get 4 plus or minus 7. Now don't leave it like this. We can simplify it. So we do 4 minus 7, which is a negative 3, and 4 plus 7, which is 11. And that one has 2 solutions. The next one, we have to get the kind of the x squared, the function by itself. So we're going to add 5 first. So we have 2 times x plus 2 squared equals 13. Then I'm going to divide by 2. And I get x plus 2 squared equals 13 over 2. So I'm going to square root this. Don't give me a decimal. Keep it as a fraction. And I get plus or minus. Okay. And I get x plus 2 equals the square root of 13 over 2, plus or minus. Okay. But I can't have a fraction side of a radical, so I'm going to rationalize this denominator. So I'm going to show that to you. So we're going to split this up into the square root of 13 over the square root of 2, and to rationalize that, we have to multiply by the square root of 2 on top and bottom, and that gives us the square root of 26 over 2. Okay, so we're going to rewrite this as x plus 2 equals plus or minus the square root of 26 over 2. Then we're going to move the 2 over, so we have a negative 2 plus or minus the square root of 26 over 2. And this still is not in simplest form, so we're going to have to, when we add or subtract fractions, we have to get a common denominator. So I'm going to rewrite that negative 2 as a negative 4 over 2 plus or minus the square root of 26 over 2, and then we can combine this, and our final answer is a negative 4 plus or minus the square root of 26 all over 2. So make sure we remember how to rationalize our denominator, simplify our radicals, and get it in simplest form. Our next one is more square roots, but we're using fractions. Now remember, to get rid of a fraction, we multiply by the common denominator. In this case, it's 5. So we get x squared plus 10 equals 3x squared. Subtract the x squared. We get 10 equals 2x squared. Divide by the 2. We get x squared equals 5. Square root both sides. Plus or minus. So x will equal plus or minus the square root of 5. That one was quick. Okay. Our very last one on square roots, we have to get the function by itself, so we divide by 2. We get x minus 4 squared equals a negative 5 over 2. Square root both sides. But I'm going to stop right here because I have a negative underneath that radical, and for right now we cannot have a negative underneath that radical. So the answer for this one is no real solutions. All right, and our very last one is by factoring. So we just have to refresh our memory on factoring. So when we factor this, we need 2 numbers that multiply to be 25 and add up to be a negative 10. Well, that would be negative 5 and negative 5. And whenever we factor to solve, we set each factor equal to 0. Well, since they're the same thing, we just have to set 1 equal to 0. So z will equal 5. This one we have to get in standard form, so we're going to add the 30. 2 numbers that multiply to be 30 but add up to be a negative 11. That's a negative 5 and a negative 6. Set both equal to 0. So x will equal 5 and 6. And our very last one, this is a special pattern, and if it's a difference of 2 squares. And when we have a difference of 2 squares, we just do a plus or minus and the square root of that last number, 49, which is 7. And we're going to get a is equal to plus or minus 7 if we set those equal to 0 and solve.